In this module, we will discover more about how Norgren products control the direction or flow of air. You will learn about different types of valves, how they work, and the benefits and limitations of different designs. We will also cover product selection and identification to ensure you can find the right product for your customer. Control valves are sometimes referred to in different ways by customers. Here are some of the terms used. It is also worth remembering that some customers still mention legacy brands like Martinair and Enots, as well as Norgren, Bushost, and Harion when referring to our control valves. What does a valve do? A valve blocks or diverts the flow of compressed air within a system. This is usually to either move a cylinder, air tool, or air motor directly, or to move a pilot that acts as a signal to activate another part of the system. In practice, that means the valve will serve one of two functions. The first is to start or stop the flow of air, like a tap or a light switch. The second is to change the direction of airflow by driving one of two outlets. There are a number of valves to choose from. The best way to decide which is most appropriate is by considering the following: valve body and function, valve operator, valve size. The function of a valve is determined by two attributes: the number of ports and the number of positions. They are commonly displayed like this. The first number represents the number of ports on a valve. Only the ports on the main body are counted, and the smaller ports on a pilot valve, for example, are not included. This is a 2-2 valve. It has two ports and two positions. Port 1 is the inlet or supply. Port 2 is the outlet or output. This is a standardized numbering system. The two positions are open or flow and closed or no flow. The operation of the valve is also indicated by a number. In this case, it's 1-2. 1-2 refers to the flow of air from port 1 to port 2. So this 2-2 valve with 1-2 or 1-0 operation works as follows. In position 1, labelled as 1-0, the valve is closed and there is no airflow. In position 2, air flows from port 1 to port 2. This simple valve is similar to the tap over a wash basin. When it is in one position, water flows. In the other, it stops. This is the symbol for a 2-2 valve that you may see on a system diagram. Each box represents a position. Each number represents a port. The illustration also includes a button and a spring. In position 1, no air will flow, often called the 0 position and illustrated with a T-shape. In position 2, air flows from port 1 to port 2, as illustrated with an arrow. A 3-2 valve has 3 ports and 2 positions. It works in a similar way to the 2-2 valve, but with the addition of an exhaust, labelled as port 3. This valve also has 1-2 and 1-0 positions. However, when in the 1-0 position, the air from port 2 is vented through port 3. Here is a simple example of a 3-2 valve operating a single-acting spring return actuator. Initially, the system is at rest, the button is not pressed, and the valve is in the 1-0 position, so no air is passing to the cylinder. When the button is pressed, the valve moves into the 1-2 position and air passes through the valve to the cylinder. When the button is released, the valve moves back into the 1-0 position, and the air between port 2 and the cylinder vents through the exhaust port. 3-2 valves come in many shapes and sizes, but the principle is always the same, whether it's a standard valve, a ball valve, or a shut-off valve. A 5-2 valve has 5 ports and 2 positions. As you can see here, there is still one inlet, but now there are 2 outlets and 2 exhausts. The 2 positions are air to port 2 outlet or air to port 4 outlet. So the operation for this valve would be 1-2 and 1-4. You can see the operation more clearly in this diagram. 2 boxes represent 2 positions, and the ports are numbered. When the air flows to port 2, the air from port 4 passes to the exhaust. When the air flows to port 4, the air from port 2 passes back through the exhaust. A 4-2 valve is less common and is not shown here. These valves are similar to a 5-2 valve but share an exhaust port. Here is a diagram demonstrating a 5-2 valve operating a double-acting cylinder. In the 1-2 position, air moves through the valve and enters the front of the cylinder, pushing it inwards. Air from the back of the cylinder enters port 4 of the valve and is vented through port 5 of the valve, the exhaust. When the button is pressed, the valve moves into the 1-4 position. Air now travels from port 4 of the valve to the back of the cylinder, pushing it forwards. The air at the front of the cylinder now passes back through port 2 and out of the exhaust at port 3. 5-3 valves are also available, but should only be provided in certain circumstances. These valves have a third, normally sprung position. It can have safety implications if not used correctly. Ensure that the customer is replacing like for like. If not, then seek technical advice. Here is a summary of what we've covered. A valve operator is the device that sends commands to the valve. It tells a valve what to do and when to do it. They fall into 3 categories. Manual operators that require human intervention. Mechanical operators that are similar to manual operators but are activated by a machine or process. And finally, signaled operators that react to air or electrical signals. Air operators are referred to as pilot-operated valves. Electric signaled operators are known as solenoid valves and are either direct-acting or a solenoid pilot. Direct-acting solenoid valves are of limited use and are seen on about 10% of applications. That's mainly because flow can be limited and they consume a large amount of electrical power. Internally piloted solenoid valves serve around 90% of applications. This is by far the most common type of solenoid valve and is much more energy efficient. They use air to move the spool across, changing the position of the valve. When selecting a valve, make sure you check the minimum operating pressure range. An external pilot is usually used when you wish to extend operating pressure range for low pressure or vacuum, or when using alternative porting, so the supply air is not connected to port 1. The size of the valve that is needed will be covered on a later course, but it's an important consideration. The valve will have a flow rate, and if this is insufficient, it will limit the speed of the process downstream. At this point, it is best to match port size for port size. You can find out more about flow in the Introduction to Compressed Air module. The way in which a valve is attached to a system depends on the valve body style. The 3 most common valve body styles are: in-line is where the pipework is connected directly in line to the valve and can be the most economical option. Norgren's V60 valve is an example of an in-line valve. Manifold mounting of in-line valves allows common supply and exhausts, and working ports 2 and 4 are connected individually. A sub-base allows valves to be connected and removed without disturbing pipework. Although more expensive to purchase than inline valves, they can considerably reduce maintenance time and the risk of errors in installation. The valve can simply be unscrewed and removed at the gasket face. Sub-base valves also drastically reduce the number of components required, especially the need for fittings and silencers, as compared to an inline valve. Norgren's IsoStar range is an example of a sub-base valve. A valve island is the most sophisticated valve system and allows for just a single electrical connection, supply line, and exhaust for a series of valves. Norgren's VM10 is an example of a valve island. Spool construction. A valve spool is the part inside a spool valve that moves, either allowing it to change direction or stop. There are two types of spool: soft seal or glandless. Soft seal spools use O-rings to create better seals and allow for higher flow rates than glandless spools, but the seals will eventually wear out. The seals will either be on the spool, which is referred to as dynamic, the seals are moving, or they are held in place through the cage, referred to as static. Glandless valves have no touching parts, which means much lower wear and longer lifetime. Typically, a glandless valve can last 250 million cycles. Tight tolerances means the spools are larger so they don't change size with the resulting temperature fluctuations. As the spool and sleeve take up more space, the orifice will be smaller and limit flow. A poppet valve is less common than a spool valve and operates in a different way, with a face seal acting against a flat poppet seat. These valves come in 2-2 and 3-2 operation, but are very tolerant of harsh environments, have a low leakage rate, and can have a long life due to a lack of sliding friction. Now we have learnt about the theory, let's take a look at some of the control valves in the product range. Super X manual and mechanical valves are incredibly popular classic designs that have been tried, tested, and improved for many years, making them extremely reliable. All are inline valves with soft seal construction and have an operating pressure from vacuum to 10 bar or 145 psi. These valves usually act as a pilot or operate low flow items. They all come in 1/8 or 1/4 of an inch port sizes, with a BSPP and NPT option, and a wide variety of manual or mechanical operators. These valves are available in 3-2, 5-2, and some 5-3 functions. The polymer body version of the 3-2 valve includes both push-in and threaded ports. The V60 to V63 valves are Norgren's complete family of core inline pilot-operated and solenoid pilot valves. These valves are based on the 2-watt power-rated coil and come in 3-2, 5-2, and all 5-3 functions. There are 3 manual override options: none, turn and lock, push only. The manifold system allows manifolds of up to 20 stations. They have options for using an external solenoid pilot. The V50 series is also a family of inline solenoid and pilot valves that offer a low-cost alternative to the V60 series. They are 40% lighter and up to 40% smaller than the V60 series, but do have some limitations, including lower flow, so may not be appropriate for all applications. They do not offer external pilot options and can only be fitted in a manifold of up to 10. In most circumstances, it is better to offer the V60 series first. They offer a combined turn and lock and push-button override. ISOstar are Norgren's range of SXE and SXP ISO valves. The ISO standard means these valves have a standardized footprint and are interchangeable with other manufacturers' products. It's only the footprint that is standardized though, and the operating parameters of the valve are not covered. The ISOstar valves come in 3 sizes. ISO 1, 2, and 3 each offer different flow rates. Size 4 is available in the UM22000 series. The valve has a glandless design offering a very long life with fast, accurate, repeatable switching time through its lifetime. Its standard operating pressure is up to 10 bar or 145 psi, but the external pilot or higher power solenoid versions are capable of operating with a pressure of up to 16 bar or 232 psi. The valves themselves don't have ports, but the bases come in BSPP or NPT, 1/4 inch, 3/8 of an inch, and 1/2 inch sizes. Norgren offer a number of valve islands. The main products are the valve manifold, or VM, and the valve subbase, or VS ranges. The main benefits are a customer-specific design with common connections, reduced complexity and installation time, and they're ready to use out of the box. Process valves control the flow of fluids and solids. Norgren, Buschhost, and Herian offer a full range of solenoid and pilot-operated process valves. Pressure switches can either be electromechanical or electronic. They take a pneumatic signal input and give an electrical signal output at a given point. Norgren and Herian offer a full range of pressure switches. Proportional valves regulate the air pressure or air flow depending on an electrical input. Norgren offer a full range of proportional valves. We've looked at some of the most common valves in this film, but there are a plethora of valves and options, some of which are very similar, as you will see if you look in the catalogue. Product identification. It's important that you understand how the product numbers relating to each of the valves are generated. Most products have a standard number that you will find in the catalogue, and where possible, it is best to stick with these. If you do need to create something bespoke, then please use the datasheet to change the functions you are updating. Let's work through an example with a typical part number. Digit 1, 2, and 3 relate to the port size. Digit 4 gives us the thread type. Digit 5 is the valve operation. Digits 6 and 7 reveal this is an internally piloted solenoid spring. The dash or hyphen is always between digits 8 and 9 and is fixed. The following digits are usually the most relevant when it comes to bespoke options. Digit 10 tells us the manual override option. Digits 11, 12, and 13 relate to the coil code from a table. Finally, if the product is a spare or replacement and required with no solenoid coils, then replace the coil code with 3 zeros. With every valve sale, there is the opportunity to add value for the customer. Our cross-selling initiative is all about providing customers with peripheral products to ensure they get the most from their system. Here are some examples. Most valves need fittings to connect pipework. A 3-2 valve will require 2, and 5-2 or 5-3 valves will require 3. If it's a pilot valve, it will need a further fitting for a pilot spring, or 2 fittings for a pilot to pilot. Every valve with an exhaust needs a silencer to stop the ingress of any dirt into the exhaust ports. A solenoid will require a plug and a lead to connect the solenoid to the machine. Basic plugs are cheaper, but pre-wired plugs reduce the chances of errors in wiring and make the customer's life easier. They may well be more cost-effective. Flow controls offer the client the ability to control the speed of the circuit, bringing it in line with other parts of the process. ISO valves can be specified with sandwich flow controls, allowing the flow controller to be fitted with the valve. That's the end of the module. You should now have a good understanding of the basic workings of control valves, the Norgren range, and how to select the most appropriate solution for a customer. More details will be covered in the intermediate course.